Hi everyone, today we're covering section 14.3, finding measures of angles inside right triangles. Now she already should have gone over the homework for today, which was a review, or not a review, but this slide is going to be a review of our homework that we did yesterday, so hopefully you did okay with that. Just finding the missing angles and the missing side lengths. Here we are finding a missing angle, angle S, but we know that all the angles of a triangle have to add up to 180 degrees. So if we have that 180 degrees and we take off for the right angle, which is 90, and we take off for angle R, which is 60 degrees, we're left with angle S, and that of course is 30 degrees. So angle S is worth 30 degrees. We're also asked to find side length R, this value right here, and we are given angle S, or angle R. So we're going to go through and write what we are trying to find, which is the side opposite our angle R, and we're given two sides. We're given the adjacent and we're given the hypotenuse. So it's up to us what we'd like to do, and I'm going to choose to use the hypotenuse. I only need one of them, because if I would use both of them, I'd be trying to find for a value that I don't need. But I'm looking at which one has the opposite and the hypotenuse, and that, of course, is sine. So the sine of our angle 60 is the ratio of the opposite over the hypotenuse. And since we're dividing by r by 12 on the right hand side, we can multiply both sides by 12 to cancel out and get r by itself. So we need to grab our calculators, and I'm going to make sure mine's in the right mode, which it is. So I could take 12 times the sine of 60 degrees. And it's about 10.4. So r is approximately 10.4. Today what we're going to be looking at is how we can use our calculator to find for missing angles. So please pause the video right here and go ahead and use your calculator to evaluate each of these. Take your decimal places to 4 decimal places. And write those in your notebook. So taking a look at the first one, the cosine of 60 degrees is 0.5, and you can have 0, 0, 0 after that, but it is exactly 0.5. The sine of 36 degrees is 0.5878. It becomes 8 because when we round that one up, we're looking at the number after, so it goes to 8. And the tangent of 14 degrees is 0.2493. So what we're going to do is we're going to take a look at when we're missing the angle. And what we do have is we know that when we have the cosine of any angle, it is the ratio of the adjacent over the hypotenuse. So this number, 0.9613, is exactly the type of number you would get when you plug numbers in to the tangent, sine, and cosine using your calculator. This number is what you get when you divide the adjacent by the hypotenuse. Whatever these two numbers are, you get 0.9613. What we want to do is we need to find the angle. So, like we did on our other problems, when we have x divided by 12 equals a number, we want to undo the dividing by 12 because that's what's happening to x. Well, right now, on the left-hand side, we are multiplying, it looks like, x pi cosine, but this is an operation all by itself. So we need to undo the cosine, and the way we do that is called the inverse. So we're not dividing, we're taking the cosine inverse, and the cosine inverse will tell us what angle will have its adjacent over the hypotenuse always be 0.9613. Regardless how big it is, it's just looking at that ratio. So the cosine inverse and the cosine cross off. So we have x equals the cosine inverse of 0.9613. On our calculators, what we're going to be doing is we're looking for the cosine inverse. I'm going to clear that off. So here's our sine, cosine, and tangent keys. But what we're looking for is this cosine inverse. And on my calculator, it's written in yellow. And anything that's written in yellow, if I want that to appear in my calculator, I have to hit the second key because that's what's in yellow. So you need to take a look at your calculator, and some of you will have it written right behind your cosine key. Most of you should. So what you need to do is you need to hit second cosine, and we're going to punch in 0.9613. If your calculator is a little bit different, you're going to need to punch in 0.9613 first, and then take the second cosine. But if we press enter, we can see it says 15.992. And if we're rounding to the nearest tenth of a decimal, this can get rounded up to 16. So x is approximately 16 degrees. So a 16-degree angle will have a cosine of the adjacent over the hypotenuse being 0.9613. So we're going to try that again with our tangent function. It says the tangent of y is 1.1106. We need to undo taking the tangent. So we're going to get tangent by itself by taking the tangent inverse. The tangent inverse of 1.106. So we're going to plug this into our calculator. Instead of using our tangent button and instead of using our second cosine, we're going to do second tangent of 1.1106. And this is about 48 degrees, because if we would round these up, this would go to 48 degrees. So y is approximately 48 degrees. So you're going to see a couple problems like this tonight on your homework, but what you're mostly going to be seeing is asking you to find the angle. So please take a minute and draw this picture in your notebook, label it exactly as I've written, and label the sides. We need to make sure that we're using a right triangle, so it is important to put that box there because that tells us it's the 90-degree angle. We're trying to figure out how big angle A is, so I'm going to mark this up, and I'm going to label my sides for the given information. It told me that BC is 6, and that is the side opposite angle A. AB is 10, and that is, of course, the hypotenuse. It's opposite the right angle. So we need to go back to our SOHCAHTOA and take a look and see which one we're going to use. Which one has opposite and hypotenuse? So if you guessed sine, you got it right. So we need to take the sine of some angle. So the sine of angle A is the ratio of the opposite over the hypotenuse. This is a fraction that can be reduced, but I'm not going to worry about it right now because my goal is to find angle A. So I want to undo taking the sine of angle A by using the sine inverse to both sides. If I take the inverse sine of a sine, that goes away, and I'm just left with A on the left-hand side. So A is equal to the sine inverse of 6 divided by 10. On my calculator, I can just go ahead and plug that in right away, the sine inverse of 6 divided by 10. On other calculators, you might need to take 6 divided by 10 and then hit your second sine, but you might want to press enter on that one first. So it looks like angle A, if we rounded it to the nearest whole angle, let's get that back up again. Angle A, if this is over 5, we're going to bring that up. So this is about 37 degrees. And that's what I was asked to solve for. Here's your next example. Please draw this in your notebook, and you can pause the video here if you need to, but make it look exactly like this. Our directions say find the measure of angle X. Here's our angle X. So what I'd like you to do is take a minute and see if you can mark up the sides that are given correctly. .325 is the side opposite. 400 is the adjacent side. So we're going to look at our SOHCAHTOA and establish which one of these we're going to use. Opposite and adjacent, that's our TOA. So the tangent of angle X is equal to the ratio of the adjacent, of the opposite over the adjacent. So we've got 325 over 400. So to get tangent by or to get the x by itself, I want to undo the tangent. So we're going to take the tangent inverse of both sides, because whatever we do to one, we have to do to the other. So x equals the tangent inverse of 325 divided by 400. I'm going to grab our calculators and plug that in. So about 39 degrees. All right, angle B. Go ahead and see if you can pause this video and solve this one all on your own. All right, you can see that I've marked up my triangle. I've got my angle B highlighted because that's the angle I'm trying to find. I have the opposite side and the adjacent side. And we're going to go through and see which trig function we have. So if we do our SOHCAHTOA, you should have found that you need to use your tangent. So we can set it up. The tangent of angle B is the ratio of 80 divided by 7. And we're going to take the tangent inverse to both sides. So we have the tangent inverse of 80 divided by 7 is angle B. So angle B turns out to be 85 degrees. And we're going to do one more before we're done for today. So we're going to try to find angle B in this situation. So please pause the video and see if you can do this problem all by yourself. So as you can see, I've already marked up my triangle. Angle B is highlighted. The 9 side is my adjacent side. The hypotenuse is 32, and those were two givens. So if I'm looking at my SOHCAHTOA, I'm looking for adjacent and hypotenuse, and that of course is the cosine, the adjacent and the hypotenuse. So we can set it up. The cosine of angle B is the ratio of my adjacent over my hypotenuse, so 9 over 32. And then we're going to take the cosine inverse of both sides so I can get B by itself. So B is equal to the cosine inverse of 9 over 32. And when we plug that into our calculator, B is approximately 74 degrees. So the only time you're going to use your cosine inverse, your sine inverse, and your tangent inverse is when you're trying to find an angle. Otherwise, the sine, cosine, and tangent will allow us to find for side lengths. So this is it for the notes for today. You will get your homework shortly. Please make sure it is done for Monday and use the rest of the time to work on that and any missing work you might have. I'll see you on Monday.